Hi, so let's talk about how I'm gonna teach you to develop the intuition for LEETCODE 332 Reconstruct Itinerary. So let's understand the question. So we're given a list of airline tickets where tickets is from to. So for example, JFK to LGA. To represent the departure and the arrival airports of one flight, reconstruct the itinerary in order and return it. All of the tickets belong to a man who must depart from JFK, so you know JFK must be the starting point. And if there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. So LGA has a smaller lexical order than JFK LGB. Basically, it must be in alphabetical order. So the airports that are of a smaller lexical order, let's just say they have A instead of B, they must come before A and B if you can go to both equally at the same time. For instance, you have the ticket JFK to LGA, LGA to JFK, JFK to LGB, and LGB to JFK. You gotta go JFK, LGA, JFK, LGB, JFK. Right? So you may assume all tickets form at least one valid itinerary. You must use all tickets once and only once. So this is basically the solution, but it looks rather scary. So how are we going to develop an understanding of how this algorithm works, right? So rather than have me tell you, I'll actually show you. So at my website, let's hope everything goes well today. You're going to be able to see that we have 3 reconstruct itineraries here. And basically these 3 algorithms will help you understand why the solution is the way it is. But the truth is you actually probably only need to focus on this one and maybe either this or this. Well, probably this is a little bit more complex. So I'll actually go through this really quickly. So it's basically a game you can play and you're supposed to choose the code based on the local variables. So as you know, these are the tickets and I'm actually going to zoom in just a little bit. And we're going to be able to choose the line of code that needs to be chosen. So first, if you initialize the function, then we create targets. So now you can see targets is basically a dictionary, right? So I'm not even gonna tell you in words how the algorithm should work. You should observe for yourself how the local variables are changing based on the lines of code that we are going to be choosing. And you're actually going to have to choose yourself. If you make a mistake, like you choose something ridiculous, then your mistake count can increment. Okay, so next thing, now you create the targets, which is an empty dictionary. So what do we do next, right? Probably we can loop through it, and now you see we loop through in reverse order. This is to address the lexical thing. And what we're trying to do is, you'll see it, but basically, you'll see it as we go. So if not targets, okay. So basically you're trying to construct something out of this. Then this is now the local variables. Then you create this, okay. Then you append this. But I think this line of code might not be necessary in Python because like the moment you type this, it's already created. So you can straight away go to this. Then you append. So that might have actually been a mistake that I made. And then you loop through again. Check this again. And you just append. Okay, actually you need this first because it was not, so the condition was met. But that was a duplicate. So you just keep doing that until you build up something. And what we're trying to build up, you can see the actual targets changing, right? So basically nRT key here, value JFK value nRT, right? Okay, and now again JFK also can go to KUL. So what is this? This is basically, now that you've seen it get built, right, it's basically an adjacency list, right, whereby you have the key of the starting airport, and then the list is basically the nodes that it can go to. So this is how you build up an adjacency list. So that's actually the first part of the question. Then now you create a stack and a route. So the stack starts with JFK, the route is basically empty. Okay, so you're trying to see, hey, what's going on? What are we gonna do? So let's take a look. So okay, we choose while stack. So while there's still something in stack, which there is. Next line is while target stack -1. So by the way, if you ever forget the algorithm, you can just click show code here, and then you can see, okay, so this is what happens. So you can guess from looking at the algorithm what the next line of code might or might not be, because it may not be linear. There's a loop. Next, stack.append. Oh, I got it wrong. So while target stack -1. So looking at this, what it does is it checks JFK. So that's the last element of the stack, and it does show that the array, the list that is pointing to is not empty. So this condition will be met. Then stack.append. So you add stuff to the stack now. You can ignore tickets and these two for now, the ticket and tickets, because this one was in the for loop. So you can just ignore it. We'll just be using targets and stack. So now it adds KUL, it pops it from here and adds it to the stack. Next thing it does is that it goes back to the same for loop, which checks the last digit and checks KUL here, which is empty, so the condition is not met in actual fact. So that means that you will go to route.append. Now, what's interesting about this KUL, if you look at the targets, JFK to KUL, JFK to NRT, NRT to JFK, right? So KUL is actually a dead end, because when you go to KUL, you cannot come back. So what's interesting is it pops it to the route first. So what this means is that when it's a dead end, it must be visited last, because there's no way to come back. That's the only way you can construct a valid itinerary, whereas you can go to NRT first and then come back from NRT, right? So next, we go back to while stack, while target stack, okay, we check there's something here, okay, this condition, wait, sorry, it's JFK now, check it is met, then after that you will basically append, and then we continue to check NRT, and NRT here there is something, so we continue to append that, and then JFK, NRT, JFK, then now we check JFK again, and you'll find there's nothing, so now you can route.append, right, KUL JFK, then you go back to the route while the stack is not empty, route .append again, oops, sorry, while stack, oh sorry, we need to check this other condition first in the while loop. So this enforces a lot of discipline in understanding how the algorithm works. Route.append, while stack, while targets, route.append, while stack, nothing now, so that is no longer, so just return the route, and that's basically it. But this is returning the route in reverse order, so the route stays the same, but now it returns the route. So it starts from JFK, as you know, so this was KUL, as we mentioned earlier, the dead end, so it's going to be the last thing that's visited, and so JFK, NRT, JFK, KUL, so return. So that's basically the full explanation, and you can go to my website, this link here, the link will be in the description below, to understand how exactly this algorithm is working. So you can click show code here. This is similar kinds of, it's basically identical in the algorithm, the syntax might differ a little bit, but basically it's the same algorithm, and different arguments, so you can see how when the local variables are different, how the code is changing, and from that you will understand the logic and intuition behind this algorithm, and you'll be able to implement it in any programming language you like. Thank you so much, have a good day, bye, see you.